Okay, 7.3 and 7.4 is about probability. Probability is a measure of the likelihood of a random phenomenon or chance behavior. Probability describes the long-term proportion with which a certain outcome will occur in situations with short-term uncertainty. Alright, so there's a very mathified definition for you. Every probability has a value that is between 0 and 1 inclusive. So the probability can be equal to 0, in which case that event is considered impossible, and the probability can be equal to 1 when the event is a certainty. Alright, so number 1, suppose a fun-sized bag of M&Ms contains 9 brown, 6 yellow, 7 red, 4 orange, 2 blue, and 2 green. And then suppose that a candy is randomly selected. What is the probability that it's yellow? Well, first we need to know the total number of candies in the bag. So 9 plus 6 plus 7 plus 4 plus 2 plus 2. Alright, so let's see. Okay, so that's 30. So 30 total. So what is the probability that a randomly selected candy is yellow? Well, there's 6 yellow. So that's going to be 6 out of 30, which reduces to 1/5. And if they wanted you to enter that as a decimal, you just do 1 divided by 5, which is 0.2. What is the probability that it's blue? Let's see, there's 2 blue. So 2 out of 30 equals 1 out of 15. What is the probability that it's purple? Well, unfortunately, this bag doesn't have any purples, so that would be 0. And what is the probability that it is, in fact, an M&M? Well, let's hope that's going to be equal to 1, since you're pulling candy out of a bag of M&Ms. It's definitely going to be an M&M. Alright, so suppose you roll a 6-sided die. What is the probability that you roll a 2? Well, there's 1 2 out of a total of 6 possibilities, so that probability is 1 over 6. What is the probability that you roll an odd number? So there's 1, 3, and 5, so that's 3 out of 6, which reduces to 1/2. You roll a number greater than 2, so that would be 3, 4, 5, or 6. So that's 4 out of 6, which reduces to 2/3. And then part D, you roll a 1 or a 6. So that's 2 options out of 6, which reduces to 1/3. And part E, you roll an even number or a number less than 2. So numbers less than 2, the only option is 1. And then the even numbers would be 2, 4, and 6. So that's 4 out of 6, which reduces to 2/3. Okay, suppose you draw a card from a standard 52 card deck. What is the probability that you would get a heart? Well, the deck of cards is split into 4 suits. So if you're not familiar with the basics of a deck of cards, you might want to Google that just to get the basic information if you need it. But I can tell you that there's 4 suits, one of which is hearts. So the deck is split evenly between those 4 suits. So 52 divided by 4 is 13. So that's 13 out of 52. But also, since we know that that's 1/4 of the deck, we would also just know that that's equal to 1/4. Alright, and what's the probability of getting a black card? Well, 2 out of the 4 suits are black, so that's half the deck, so your probability is going to be 1/2. But you could also write it as, you know, I know there's 26 black cards out of 52, which reduces to 1/2. And then face cards. Face cards are considered Jack, Queen, and King. So there's 3 of those in each suit. So so there's 4 suits. So 3 times 4 is 12 out of 52, which reduces to 3 out of 13. And what's the probability of getting a 10? There's 4 10s in the deck. So that's 4 out of 52, which reduces to 1 out of 13. And then what's the probability of getting a red jack? There's 2 of those in the deck out of 52. So that's 1 out of 26. Alright, and then what's the probability of getting a 2 and a 3? Well, you're only drawing 1 card. So 1 card's never going to be both a 2 and a 3 at the same time. So that's going to be 0. A 2 or a 3. Well, there's 4 2s and there's 4 3s. So that'd be 4 plus 4 out of 52, which is 8 out of 52, which is going to be 2 out of 13. And then a 5 or a club. So there's 4 5s, plus there's 13 clubs, but then one of those 13 clubs is the 5 of clubs. So you've counted that 5 of clubs twice, so that's why you need to subtract 1 here. And then put that over 52. So that would be 16 over 52, which would be 4 over 13. Alright, suppose 2 dice are rolled. Find the probability of getting the sum of 8. Okay, so the nice thing about this diagram, that shows all the different possibilities that you can have when you roll 2 dice, and along the diagonals you've got the same sum. So sum of 8. So here's the ones that have sum of 8. So there's 4 of those. So that would be 4. And the total, there's 6 options for one die, there's 6 options for the other. 6 times 6 is 36. The total is 36, so that's 1 out of 9. Alright, and then a sum less than 5. So that's going to be less than or equal to 4. That's just those. There's 6 of those. That'd be 6 out of 36, which reduces to 1 out of 6. And then an even number on the first die and an odd number on the second. Alright. So an even number on the first. So it could be a 2. These all have a 2 first. These all have a 4 first. And these all have a 6 first. So those are an even number on the first die and an odd number on the second die. So it could be a 1 on the second die, or a 3 on the second die, or a 5 on the second die. So basically the ones where the green and blue, the ones where the yellow and blue overlap to make that green, those are the ones we're going to count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 green ones out of 36. That's 1 out of 4. And then the same number on both. We got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there's 6 of those. So that'd be 6 out of 36, which would be 1 out of 6. Okay. So an event is any collection of outcomes from a probability experiment. Let E be an event. Then the complement of E, denoted E apostrophe, or sometimes read as E prime, is the event that E does not occur. E and E prime are called complementary events. Let E and F be events. The union of E and F, denoted E union F, is the event that either E or F or both occurs. The intersection of E and F, denoted E intersection F, is the event that both E and F occur simultaneously. So if E intersect F is impossible, E and F are called mutually exclusive. Alright, so suppose 2 dice are rolled. E is the event of getting a sum greater than 10. F is the event that the first die is a 6. G is the event of getting a sum less than 5. H is the event of getting an even sum. So what is the probability of E prime? Alright, so that means you would be getting a sum less than or equal to 10. So to calculate this, we can do 1 minus the probability of E. So the probability of getting a sum greater than 10, here's 12, here's 11, so there's only 3 of those. So that's equal to 1 minus 3 over 36. You can reduce that to be 1 minus 1 over 12, and that would be equal to 11 over 12. And then the probability of G union F, the first die is a 6, or you have a sum less than 5. So those two events are mutually exclusive, because if your first die is a 6, obviously your sum can't be less than 5. So that would be the sum is 4 or less. So that would be all of these. And then a sum, and then the first die is a 6. That's just all of these. So there are 12 of those. So 12 out of 36 equals 1/3. And then H prime union G. So the opposite of having an even sum would be having an odd sum. So you have an odd sum, or you have a sum that's less than 5. Alright, so there's the ones that are less than 5. And then let's do all the odd sums. So if we did all the odd sums, sum of 5 would be included. And then the sum of 7 would be included. And then the sum of 9 would be included. And then the sum of 11 would be included. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. So it'd be 22 out of 36. So that would be 11 out of 18. And then the probability of E intersection with F. So that would be a sum greater than 10. And the first die is a 6. So a sum greater than 10 would be these 3. And the first die is a 6, so that would only be those 2. So that would be 2 out of 36, which equals 1 out of 18. Alright, so let's do a probability Venn diagram. So we have A and B. Alright, so the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So we're told that the probability of the union is 0.7 equals probability of A 0.46 plus probability of B, which is 0.43, minus probability of A intersection with B. So 0.7 equals 0.89 minus the probability of A intersection B. So that tells me that the probability of A intersection with B must be equal to 0.19. So that would go in here in the middle section. And then we know that the probability of A is a total of 0.46. So 0.46 minus 0.19 is 0.27. So that's what this section is equal to. And then B, that's 0.43 minus 0.19. So that's going to be 0.24. for that section. And then we also have the universal set. So to figure out what that is, we would do 1 minus, and then we could just do 0.7 to get 0.3. Okay, so the probability of A prime union B. So that's everything that's not in A plus everything that is in B. So we would have to use 0.24 plus 0.3, and then we'd also, since 0.19 is in B, we also have to put in the 0.19. So that's 0.73. And then A prime intersection with B prime. So that's everything that's not in A, and it's also not in B. So that would only just be the 0.3. And then the probability of A union B prime. So we could rewrite that as 1 minus the probability of A union B prime. So that would be 1 minus. So everything that's in A would be 0.27 plus 0.19 union with B prime. So then you have to include everything else that's also not in B. That would be plus 0.3. So that's 0.24. Alright, number 7. Of the students at Harper College, 60% are female, 35% live on campus, and 18% are females who live on campus. If a Harper College student is selected at random, find the probability that the student is a male. Alright, so let's say these are female. These are the ones that live on campus. And it says 18% of the students are females who also live on campus. So the intersection would be 0.18. And it says 60% are females, so this would be 0.60 minus 0.18, which would be 0.42. And it says 35% live on campus, so this would be 0.35 minus 0.18, which would be 17, 0.17. And then this would be 1 minus 0.42 minus 0.18 minus 0.17. That's 0.23. Okay, so the probability the student is a male. So that's going to be everything outside of the female circle. So that would be 0.17 plus 0.23. So that would be 0.4. We could have also figured that out by just doing 1 minus 0.6. A male who lives off campus, that's going to be your 0.23. Alright. Does the following satisfy the conditions of a probability model? Well, we know each probability has to be a number between 0 and 1. So for number 8, that is true. However, this is between 0 and 1, this is between 0 and 1, and this is between 0 and 1. So those are good. However, then we have to also make sure that the sum of all the probabilities adds up to equal 1, which adds up to equal 1.3. So since that's not equal to 1, then no, this is not a possible probability model. Alright, now number 9, if we were to add all of these up, we would get, wait a second. Yeah, we would still get a number that's greater than 1, which is, this would actually be 2, equal to 2, which is definitely not equal to 1. And then also, the other thing is the fact that this is less than 0, and this is greater than 1. So those are all some great reasons why this does not qualify as a possible probability model. Alright, so that's all. Hope you found it helpful.